All right, so now we're doing the same thing, but this time our quadratic equation is going to be given in vertex form. Now, vertex form is in the form of y is equal to a times x minus h squared plus k, where your h and k value are your vertex. Now, we need to be careful with the h value. I always like to say the h value is hard, because it's the hard one to remember, because the h value in my equation is in terms of a minus sign. So the actual h value is the opposite of what it looks like. If it looks like a minus h, then it's really just h. If it looks like a plus h, then it's a negative h. So let's get started. So for number 1, we still look at our a value. There is an a value of 1 technically in front of this set of parentheses. And since it's a positive 1, that means our direction of opening is up. Now my axis of symmetry is different. And sorry, this is a typo. This should say vertex form. My axis of symmetry is different because I don't need to do the x is equal to negative b over 2a. I only do that for standard form. We know that the vertex of this quadratic equation is actually, remember h, your h value is hard. It's the hard one to remember. It looks like a negative 2, it's really a positive 2. And then your k value is exactly what it looks like, it's a positive 1. So my vertex is 2, 1. So for my axis of symmetry, this is actually really easy because my axis of symmetry is technically the x value of my vertex. However, we have to remember that we write the axis of symmetry as a vertical line equation, which is x is equal to 2. Now a reminder that the axis of symmetry is an imaginary line running through the parabola and cuts the parabola in half. And my vertex here is 2, 1. So it's right there. Now remember that rule of to graph the rest of your parabola, your a value times 1 gives you your next point on the graph. So a times my a value is 1, so 1 times 1 is 1, so that means I go up 1 and over 1 on my graph. And then my a value times 3 gives me my next point. So a 1 times a 3 is a 3, so I go up 3 for my new point and over 1. And then now I'm going to reflect these points over my line of symmetry just by counting. And this is what your parabola looks like. Make sure you label this. This is number 1 on my graph because we're going to graph all of these on here. Now, we should notice that this parabola is not going to have any x-intercepts. So right away we can write that the x-intercepts are none. There's no real number solutions here, and there's no, for x-intercepts we can just write none because there are no real x-intercepts and there are no imaginary x-intercepts here. This graph's not going to cross the x-axis, so there are no x-intercepts. However, I am going to require you to prove that to me by using either the quadratic formula or completing the square. You cannot prove that there are no x-intercepts by factoring. So here's how we do this. First, we need to convert this into standard form. So I have the equation y is equal to an x minus 2 squared plus a 1. We need to convert this into standard form. I'm going to show you that shortcut way that I showed you in the last standard. Y is equal to, then I square my first term, which is x squared. I multiply the two terms together, then multiply by 2. So a negative 2 times an x is a negative 2x, times a 2 gives me a negative 4x. And then I square my last term, and negative 2 squared is a positive 4, and I cannot forget I have this plus 1 on the outside. So now I have y is equal to an x squared minus a 4x plus a 5. So let me show you, again, we're proving that there's no x-intercepts here by using the quadratic formula. X is equal to the opposite of b, that would be a 4, plus or minus the square root of b squared, which is a 16, minus a 4 times my a times my c, all over 2 times my a. Now, when we put the numerator in parentheses, x is equal to 4 plus or minus the square root of 16 minus a 4 times a 1 times a 5 gives you a negative number in parentheses, or sorry, not in parentheses, underneath your square root, which we know from there that causes a red flag. We cannot have a negative number underneath our square root and wind up getting a solution. We get imaginary solutions. So my x-intercept here is none because, again, it doesn't cross the x-axis. We don't write no real number solutions. We just write none because we're saying, where does it cross the x-axis? Well, it doesn't. So there are no x-intercepts. All right, looking at number 2, same thing. My a value is positive. It's a positive 2, so this is going to be going upwards. Let's do our vertex first. My h value is the hard one to remember. It's the opposite of what it looks like, so that's a negative 2. My k value is exactly what it looks like. That's a negative 1. And that is your vertex, negative 2, negative 1. Now your axis of symmetry is the x value of your vertex, and we write it as an actual equation. X is equal to negative 2 because it's a vertical line. I'm going to do this one in yellow so that way we don't get confused. Oops, and I totally graphed it wrong. X is equal to negative 2 would be right here. And then now I'm going to graph my vertex, which is at negative 2, negative 1. That's this one here. All right, to get my next point on the graph, I take my a value and multiply by 2. So, and multiply by 1. My a value is 2, I multiply by 1, and so my next point is up 2 and over 1. Then I take my a value, which is 2, and I multiply by 3, and that is going to be 6. So I go up 1, 2, 3, 4, 5, 6, and over 1. And now I'm going to go ahead and reflect those points over my yellow axis of symmetry. And now I can sketch my graph. Make sure to label our graph that this is graph number 2. Now I'm going to be finding the x-intercepts, and it looks like I can't really estimate those on the graph because they don't intersect the x-axis at a whole number point. So I will need to use the quadratic formula or completing the square to do this one. But before I do that, I need to convert this into standard form. So right now I have y is equal to a 2 times, and now I'm going to do the x plus 2 squared by squaring the first term of x to get an x squared. A 2 times an x times a 2 would give me a plus 4x, and a 2 squared is a 4. And then I have that minus 1. Now I'm going to distribute this 2 into parentheses, so I have a y is equal to a 2x squared plus an 8x plus an 8 minus a 1. Now I have y is equal to a 2x squared plus an 8x plus a 7. All right, I'm going to do the quadratic formula to find out my x-intercepts. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times my a value times my c value all over 2 times my a value. So I wind up with negative 8 plus or minus the square root of, and then doing a 64 minus a 4 times a 2 times a 7, I get 8. And then this is all over 4. So in my calculator, I'm going to put parentheses in where appropriate. So I do parentheses negative 8 plus the square root of 8, close your parentheses twice, divided by 4, and I'm going to round to my nearest hundredth, so negative 1.29. Then I do the same thing, only I do minus instead of plus, and I should get a negative 2.71. Those are my x-intercepts. Moving on to number 3. My a value here is a negative 1/2. So this means that it's going to open down because it's a negative number. We're going to do my vertex first. Remember, your h value is the hard one to remember. It looks like a positive 4. It's really a negative 4. Your k value is exactly what it looks like. So my vertex is at negative 4, 6, which means my axis of symmetry is x is equal to, and then the x value of my vertex, which is negative 4. I'm going to draw my axis of symmetry in black this time. So I have my vertical line running through negative 4. All right, my vertex, again, is negative 4, 6, so I'm going to plot that on the graph now. Negative 4, 6 is right here. Now this is going to be facing downwards. To get my next point, I do my a value, which is negative 1/2 times 1. Well, a negative 1/2 times a 1 is a negative 1/2, so that means I go down 1/2 and over 1. Now I'm going to do negative 1/2 times 3, which is a negative 1.5. So from my new point, I go down 1.5 and over 1 to get my next point. So now I'm going to reflect those points over my axis of symmetry, which is that black dotted line. And this is what my parabola looks like. And I'm going to mark this as number 3, so I label my graphs here. All right, now looking at the x-intercepts, we do, this will have an x-intercept eventually. We didn't draw it in, but we do need to get this in a standard form. So I really have a y is equal to a negative 1/2 times, and then now I'm going to use the shortcut. I square my x, I multiply 4 and x together, and then multiply by 2. 4 times an x times a 2 is an 8x. Then I square my 4. And then I have a plus 6. Distributing the negative 1/2 in, I have y is equal to negative 1/2 x squared minus a 4x minus an 8 plus a 6. So I have y is equal to a negative 1/2 x minus a 4x minus a 2. Now we have not worked with, sorry, this should be a negative 1/2 x squared. We have not worked with the coefficient of x being a fraction. So let's actually, to find our x-intercepts, I didn't say this for the rest of these, but we should be substituting 0 in for y when we're finding our x-intercepts. And now what I'm going to have you do, because we haven't worked with any fractions, I'm going to have you multiply this entire equation by 2. So I have a 0 is equal to a negative x squared minus an 8x minus a 4. And now let's do that quadratic formula. Again, if you want to do completing the square, you are more than welcome to do that. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get an 8 plus or minus the square root of, and a 64 minus a 4 times a negative 1 times a negative 4 gives us a 48. And then this is all over negative 2. Putting parentheses where appropriate, doing parentheses 8 plus the square root of 48, closing your parentheses twice and dividing by 2. We're going to round to the nearest hundredth. My first x-intercept is about negative 7.46. Doing the same thing only with a minus sign, my other x-intercept is about negative 0.54. So we couldn't have used factoring on any one of these, because factoring can only be used if I wind up with whole number x-intercepts or fractions that end. These are fractions or decimals that go on forever and ever and ever. So the only one that I could have used is quadratic formula or completing the square to solve for my x-intercepts on these. All right, that brings us to the end of the levels 1 and 2. Now you're going to practice.